Welcome everybody. This presentation is about ProxySQL and mirroring. So what we do basically we do support, but we'll just skip here. Who am I? I'm René Cano. I'm the author of ProxySQL, founder of the same company. My background is a MySQL DBA for quite a long time. So quick overview of what is ProxySQL. How many of you are familiar with it or know it? Great. How many of you are using it? Okay, great. Okay, so basically, in a nutshell, what it is a proxy that is protocol aware and that sits between the application and the backend, the MySQL server. It gets requests from the application, it processes them, decides what to do with them, and then performs action based on some internal logic. It is all programmable. Okay, so there is a bunch of features that I'm not going to go on this presentation, but the most important features that we are going to discuss is about multiplexing. And the reason behind this is to try to solve one specific problem that is quite common in MySQL. In MySQL Server, when you have a lot of connection, a lot of client connection, performance tends to degrade very badly. The higher the number of connection, like 1,000 connection or 10,000 for connection, performance drops drastically. Here we have a graphs about one specific use case in which replication was lagging, and the only reason why replication was lagging was because there were too many connections to that server. Those connections were absolutely idle. They were not processing any request. The only thread that was running and doing some work on this server was replication, and replication was just lagging. As soon as they killed all the idle connection, replication was able to catch up. And they identified this one because they had two different servers with same specs. One with connection connected to the server, one without, and the one without connection was not lagging. So the only reason why one of the two slaves was lagging was because it has tens of thousands of connection. So quick overview of what are the various threading models that this can apply on any sort of software. So you can have either one thread per connection, or in some other system you can have even one process per connection, like in Postgres, or you have some thread pool. Pros and cons of both of them. The pros of one thread per connection is that it's easy to develop, because every thread is just handling one connection. On the other hand, one of the problems is blocking I/O. So that specific thread has to handle all the specific connection and nothing else. On the other hand, if you are using thread pool, it is way more difficult to implement because you have one single thread that has to manage multiple connections, but at the same time it's way more scalable because you don't have so many connections. Sorry, you don't have so many threads. So MySQL, by default, it has one thread per connection, and of course this has some cost. The cost, again, is not specific to MySQL, but any application that use this model of having one thread per connection. Basically, in short, you have a lot of software thread, while the number of physical threads that are in the CPU are way less. So you have a lot of context switch because the CPU every time has to switch from one software thread to another one. The number of registry, it has to do all the context switching, and you have mutex and contention between all those threads. And at the same time, the CPU cache most of the time is absolutely useless because all the context has been moved in and out from the CPU cache. And for the same reason, you have to access memory. So access to memory is way more expensive than accessing the cache in the CPU. So what about implementation of thread pool? So normally what you have is one thread that is accepting all the connection, and then this thread's normally passing the connection to a set of threads pool that is that the one processing the request. In MySQL, this is not the default, but if you're using MySQL Enterprise, you have a thread pool. MariaDB and then Percona implemented their own version of thread pool. The way it works is that all the new connections are being accepted by one listener, and then this listener is passing the connection to a thread pool, and that specific thread pool is the one that is going to handle the connection until the connection disconnects. And of course, because of the use of the thread pool, performance gets a lot better if you're using this. Great. What about in ProxySQL? Implementation of thread pool in ProxySQL is slightly different. Instead of having one listener, what we have is that all the threads in ProxySQL, they are all listening on the same port. So one of the threads is the one that is going to get the connection, and it will be handling the connection until the client disconnects. So it has some pros that basically there is no context switching between the thread because all the information always stays locally to the specific thread. Of course, it has also some cons because it can be happen that the threads are unbalanced, but this is a quite rare case. Okay, so we have ProxySQL that has its own thread pool. Does this solve the problem of MySQL having a lot of connection? In reality, this by itself does not solve the problem. The reason why it doesn't solve the problem is that, of course, having ProxySQL its own thread pool, it improves the performance of the proxy, but it does not solve the problem that you might have still a lot of connection to the base server. The reason being is that a lot of proxies, if they are layer 4 proxy, but also layer 7 proxy, what they normally do is that for every client connection, they create one backend connection. So there is a one-to-one mapping. And of course, this does not scale, because if you have tens of thousands of connections on the ProxySQL, you will have tens of thousands of connections to the database server. So ProxySQL has its own different implementation. What it does is that it has its own connection pool, and when a connection is being used after it executes a query, normally this connection goes back immediately to the connection pool, assuming that the connection is safe to be shared. When a connection is safe to be shared, it means that there is no transaction running in the connection, there are no temporary table, there are no user-defined variable, etc., etc. So there are a certain number of criteria that define whether the connection is safe to be shared or not. And if it is safe, go back to the connection pool, so the next client request can be executed in that specific client connection. And so basically what we can have is that we can have thousands of front-end connections that go funneled into very few back-end connections. So basically, this is how ProxySQL performs multiplexing. So again, you can define the number of backend connection, and the number of front-end connection can be extremely higher. Of course, there are certain criteria that automatically disable multiplexing. They are listed here. For example, if there is an active transaction, the connection cannot be shared until the transaction is completed. Or for example, if there is some table lock, so if you have executed a lock table or flash table with read lock and that specific connection, that connection cannot be shared again until unlock table is executed. Same thing happens with get lock. If you execute get lock, that connection cannot be shared anymore. Surprisingly, there are still a lot of applications that use it. Other criteria for disabling being log is that if you execute set SQL log being equal to 0, after you execute this, of course, that connection cannot be shared anymore, because otherwise this means that other connection will have binary log disabled, and of course this is not something that you would desire. And multiplexing is automatically re-enabled when you issue a set SQL log being equal 1. So as soon as you enable it, the multiplexing is automatically re-enabled it. Another reason why multiplexing is disabled is when you execute create temporary table, or if you use SQL calc found rows or prepare. Prepare is the text protocol version of the prepare statement. Other reason, there are a lot of session variables that when they are enabled, ProxySQL automatically disable multiplexing. Here I listed some of them, like set unique check or set auto increment, foreign key check, and so on. If the client executes one of those, multiplexing is automatically disabled. Now, by default, it's also disable multiplexing for every query that has the app that is normally used for user variable or session variable. And no matter if you are setting it or if you are reading it. And this, of course, can be problematic if you are using some ORM or some JDBC driver that is actually, it wants to read all the session variables, so it performs some select statement in which specify this at. And so for those specific query, you are also able to create rules that automatically re-enable multiplexing if there are such queries. Okay, questions so far? Good. Okay. One important thing to remember is that multiplexing does not automatically disable routing. Those are two different concepts. So you can have multiplexing to be disabled on a specific connection, but still you can have the client that send traffic into multiple connections. So one connection to the writer and one connection to the reader, or if you have sharding, you can have one connection to one shard and another connection to another shard, and traffic is being load balanced based on certain criteria. Now, let's show some example of how it actually ProxySQL help with improving performance using multiplexing. What will follow is some example of performance improvement that we got at Shopify, that they are using ProxySQL on all their infrastructure. So those are initial testing they were doing. So basically, those are benchmark. They were running the same traffic directly on MySQL and through ProxySQL. So you can easily see the difference. I don't know if you can see the numbers, but here we are close to 15,000, while here we are barely around 700. So the number of connection was 5% of the original. So they drastically reduced the number of connection. And during the same benchmark, they noticed that basically the number of threads running, this with MySQL and this with ProxySQL. So thread running with MySQL was spiking up to 100, while when they were using ProxySQL, the number of thread running was spiking up to 25. This was the maximum. Thread inside InnoDB, before they had 80, while with ProxySQL they have some few spike to 15. And more interesting is that the queue, the thread in the InnoDB queue with straight connecting to MySQL was again spiked to 100, while with ProxySQL was flat to 0. Next. So those are other graphs of some benchmark. Let's start from down actually. So here MySQL traffic, here traffic passing through ProxySQL. The number of QPS is the same. Actually, with ProxySQL is slightly higher. So in ProxySQL they were having more throughput, and the number of the execution query time of the query before was around 25,000, while when they passed to ProxySQL was 6,000. So the execution time of the query was less when passing through ProxySQL. ProxySQL was not filtering any traffic, was not caching anything. It was just ordering the execution of the query before sending them to the server. So it was basically reducing the number of connections to the server. It also, the response time was drastically reduced. Here before, the response time was averaging at around 1,000. I think this would be millisecond. And when they switched to ProxySQL, it was around 0.3 or 0.4. So huge performance improvement. Again, those are other graphs. This is actually production traffic. So before, when they're connected to MySQL, and when they switch to ProxySQL. So it passed from around 15,000 connection to, I don't know, probably they had 300 or something like this. Thread running in MySQL, again, before they were having around 20, spike up to 35. When they switched to ProxySQL, the number of thread running was around 8, less than 10 for sure. And again, they got huge performance improvement in the total query execution time that passed from an average of 10,000 up to 20,000 down to, I think, less than 4, something like this. So huge performance improvement. Those is another graphs about some spike traffic. So when they had those spike traffic with MySQL, the number of thread running spiked to 439, huge number. And the number of QPS on MySQL was around 35,000 at this spike. When they switched to ProxySQL and they had a similar spike, the number of QPS was around 70,000. so nearly double than this throughput. But ProxySQL limited the number of connections to the database server, so it spiked, the thread running spiked to a bit higher than 100. Okay. One of the misconceptions that people normally do when configuring ProxySQL is that they configure the number of backend connections to be as high as the number of client connections. So if they expect the client to open 1,000 connections, they configure that ProxySQL to open up to 1,000 connections to the database server. In reality, this is something that you should not do. You should always try to configure ProxySQL to open way less connections to the database server. And what happens if all the client execute some query at the same time, and you have 100 client and you don't have enough backend connection? What happens is that ProxySQL will internally sort those queries based on the start time, and will basically queue them internally and execute them serialized, so based on the number of connections that are open. And as I was showing in the previous slide, this actually improved performance. And this is even more easy to understand on the next slide. So basically, this was a benchmark done in 2016, so almost 3 years ago, done by Percona. So this is some read-write workload using MySQL 5.7 and Percona Server 5.7 with thread pool, and ProxySQL limiting the number of backend connections to 200. At low number of connection, the performance of both MySQL Server and Percona Server were higher than ProxySQL, and that's expected because ProxySQL has to analyze all the traffic before executing it. But then, as the number of connections increased at around 300 or something like this, no, around 200, the performance with MySQL Server dropped drastically. The performance with Percona Server dropped as well, but because they had thread pool enabled, it didn't drop so much. When instead ProxySQL was tapping the number of connections to the database server to 200, and performance kept stable no matter how many connections were on ProxySQL. So of course, if here we were adding more connection, again, the performance in ProxySQL was going to be quite linear, while MySQL and Percona were somehow dropping. Question? Yes.
You were talking about variables and session multiplexing.
Yes.
I used the user set variable using add in a write split, and it was only replicated to the write master, but to the second, so it would have to duplicate the statement. Does it do that by now?
Okay. It doesn't duplicate, so it will only execute it to the writer, to the master, depending according to the query rules you have configured. And of course, if you are executing a select statement, the select statement has to be executed on the same connection. ProxySQL does not guarantee this. It really depends how you configure your query rules. This is why I normally say do not send all the select to the reader, because this is wrong, because your example is a very clear example of when you should not send all the select to the reader. And actually what you said, what you asked is basically, I'm highlighting this here, that multiplexing does not disable routing. So you can still have different type of routing. So like the write statement goes to the master, and the select statement goes to the slave. And if you are sending an add to the master, you should not send the select to the slave, because it is wrong. You should send it as well to the master.
Yeah, but I wanted to have the performance of the read.
Yes, but this is why what I normally recommend is that you identify which are the select that are safe to be sent to the slave. You don't send all the select to the slave.
But I can't do it with the variable, so I would have to manually figure out.
Yes, I mean, you need to understand. Sorry?
Repeat the question.
Oh, yes. So the question is about what happens if you have a query that has session variables, so specify an at, and it is a DML statement that goes on the writer, and then the select statement, you have configured ProxySQL to send the select statement to the reader. If you send in the select statement that use the same session variables to the reader won't have that session variables because you haven't executed the ML there. So what I'm suggesting is that you don't send all the select to the reader, but you only send to the reader the select statement that are okay to be sent to the reader. So you order in ProxySQL, you check from start MySQL query digest which are the query that are safe to be sent to the reader, and you only send those instead of everything. Yes?
The query times on the Shopify example, were those established connections?
Yes.
Per query?
Yes. Yes, so the question was if here, the time, not this one, actually this one. So the query time in those graphs, they were about established connection, or they were counting also the time to establish the connection. Those are about established connection. So there is, so in those graphs, you don't even see the benefit of having ProxySQL and its own connection pool, because those were already persistent connection. Any other question?
Thank you very much.
Thanks.